Hey everybody, welcome to Unit 3, Day 6. Let's talk about the mole. If I said, for example, you had a pair of socks, I bet you could tell me that a pair is equal to 2 socks, or a dozen cookies would be equal to 12. And hopefully by now, we know that an octet is equal to 8 electrons. What do all these things have in common? Well, they are all units that give us a certain amount. An amount for a pair is 2, the amount in a dozen is 12, and the amount in an octet is 8. The mole, which we abbreviate MOL, not the best abbreviation, I agree, is just the SI unit for measure of the amount of substance. It is based on the number of representative particles in 12 grams of carbon-12, which is an isotope of carbon. You might be wondering, what is a representative particle? Well, a representative particle is just a kind of particle, any kind of particle, atoms, molecules, formula units, electrons, or ions. Okay, so they base this off of 12 grams of a particular isotope of carbon. The number in the mole is 6.02 times 10 to the 23rd power. This is a very large number. It's called Avogadro's number after the scientist who discovered this number. Sounds like avocado, but it's not. It's the number of particles, so atoms, molecules, formula units, in a single mole. So just like we said, a pair is 2, a mole is this number right here, this 6.02 times 10 to the 23rd power. This is a huge number, okay? It is 6.02 with all these zeros behind it. So if you thought about it like M&M's, 6.02 times 10 to the 23rd M&M's, it would be this big of a number. So important FYI, your teacher loves peanut butter M&M's. Do with that information what you will, right? That's a lot of M&M's. That amount of M&M's would probably just cover this room in M&M's. It's a huge number. What if we were talking about things that are a little bit bigger than M&M's? Say, for example, basketballs. If there was a mole of basketballs, it would cover the entire Earth because it would be that many basketballs, 6.02 times 10 to the 23rd. That many zeros? It's a huge amount. Now, I can't show you this right now, but if you were to have a beaker with 1 mole of water in it, H2O, that would be equal to about 3.5 teaspoons of water. So in smaller amounts of things, like something that's not as large as a basketball, a mole takes up a reasonable amount of space. So what we have to remember is that atoms are very, very, very tiny. That's why we need a number that is so large, okay? That is why we have to have that many zeros after that number, because atoms are tiny. Now, here's the nice thing about 1 mole. Just like a pair is always equal to 2, or a dozen is always equal to 12, a mole always equals 6.02 times 10 to the 23rd power. So whether it's carbon atoms or H2O molecules, 1 mole is always equal to 6.02 times 10 to the 23rd power. 1 mole of anything. It could say 1 mole of pizzas, 1 mole of basketballs, 1 mole of sneakers, whatever you wanted. It's always going to be this amount of atoms, 6.02 times 10 to the 23rd. All right, so when we're talking about molar mass, this is just the mass in grams of 1 mole of any pure substance. That is the definition of molar mass. And you've seen this on the periodic table because it is equal to the atomic mass. So that number we learned before on the periodic table, the one with all the digits afterwards, that's the atomic mass. The units for molar mass are G per mol, or grams per mole. And remember, just a quick reminder, you can find the atomic mass, the average atomic mass, by looking at the elements on the periodic table. So it's just the number on the bottom in the periodic table. Here are some examples, and if you don't have your periodic tables out, get your periodic table out to help you with this. The first one says the molar mass of Cu, which is copper, is 63.546 grams per mole. Where did I get that? Did I have to do any math? Nope, it's just written there on the periodic table. So if you get your periodic table out and you find Cu, it's number 29, you will see underneath it says 63.546. Now, see up here it says no rounding, all digits are significant. That means even on some of them, if there's a lot of numbers afterwards, we're going to write them all. So next I'm going to look at gold, Au, which is number 79. The numbers after that, it's 196.967 grams per mole. Simple as that. So where it gets a little interesting, He, again, that's just the atomic mass. Where it gets interesting is if we have more than one. So like right here, okay, right there it says O2. Okay, so we want to be paying attention to that O2 because we're going to take the molar mass of oxygen from the periodic table, which says oxygen is 15.999, and I'm going to multiply it by 2. That's how I got that 31.998. Okay, that's all I did there. So get your calculators out if you don't already have your calculators. And I'll wait. Get your calculator out. Okay, let's keep going. How about chlorine? Again, we want to look at that too. That means I need to take the mass of chlorine. Okay, that wasn't a very good job highlighting that, but there's 2 of them. I'm going to take the mass of chlorine, which is 35.453, and multiply it by 2. And that's how I came up with this number here. Okay, so that's where those numbers came from. I just take the masses from the periodic table, and then I'm going to multiply them by whatever the subscript, the little number is. That's it. It's very simple. Now, to get to the molar mass of compounds, when we're looking at the molar mass of compounds, we're going to use grams per mole, again, for our units, always. Always, always, always. And then let's look at some examples. My first example is H2O, water. So the first thing you want to do is think about the mass of H. Okay, so my mass of H, we're going to look on the periodic table. It is 1.008. I got that straight from the periodic table. And then I want to think, okay, there is 2 of them because of this, right? So I'm going to say 2 times 1.008, and then I'm just going to put that on my calculator. And that is 2.016, and then I'm going to do the same thing with the O. Here there's only 1. 1 times 15.999, so that is equal to 15.999. And then how am I going to get the total? I'm just going to add these 2 together. So I'm going to take that 2.016 plus 15.999, and that will give me my mass. Okay, so that'll give me my total mass of H2O. So I can see my total right there. It is 18.015 grams per mole. And again, we don't want to do any rounding. Okay, we're going to keep all our digits there. So next example, it says sodium nitride. Okay, before we can even solve this problem, we have to first write our formula. Okay, so our 4-step formula, step 1, I'm going to write this over here. Symbols, Na. Step 2 is charges. So my charge for sodium is +1, +1. Nitride, IDE, so that means it's not in the polyatomic ion box. It's just nitrogen, Na, and N. And nitrogen has a -3 oxidation number. They're going to crisscross. And my formula then is going to be Na3N. And it's hard to fit in this box, but there it is. Okay, so we want to get the mass of Na. There's going to be 3 of them because of that crisscross. So we're going to say 3 times the mass of Na, which I get straight from the periodic table. I'm going to look down and use the atomic weight. It is 22.99. And then I'm going to set it up before I solve. I only have one N, and the mass is 14.007. 14.007. Okay, so now I'm going to get my calculator out. 3 times 22.99 is 68.97. And this one is just going to be the same, 14.007. And then just like before, we're going to add those together. So I'm going to add my 68.97 to 14.007 to give me 82.977 grams per mole. G per M O L. Okay. So on the next one is calcium phosphide. And I'm going to go ahead and show you our formulas. Remember your 4-step formula. So step 1, calcium, think about the charges, it's +2. And then phosphide is P with a -3, and they're going to crisscross. Okay, that's going to give me this formula. So the 3 came from the phosphorus and the 2 came from the calcium. And again, we're going to fill it in using the subscripts. So 3 times 40.078, 3 times 40.078 is equal to 120.234. And then I've got 2 of the phosphorus multiplied by 2 times 30.974 is equal to 61.948. 61.948 to give me a total of 182.182. Okay, so that is it. Molar mass is very simple, and we're going to continue to practice on our homework.